Good afternoon, this is Mr. Tom here. Happy you can join us for our Virtual Astronomy Day at the Museum at Prairiefire. So to celebrate, I wanted to do a little experiment for you. It's pretty fun. So what we are going to do is we are going to make craters. So I'm sure you've all seen the moon at night, and maybe looked up there and you see that some spots are a little darker than others. But I'm sure you've also seen, especially if you've looked through a telescope or binoculars, that it almost looks like they're little, almost like holes or dents in the moon. And some of you might know how those happen. But those are called craters, okay? So imagine something like this. Okay, this is just a rock I pulled out from our wetlands here. Imagine things like this flying through space and then they hit something, okay? They're not just moving, they're moving really fast. We're talking maybe 15, 20, 25,000 miles per hour or even faster. That's really, really fast, okay? Now when something is going that fast, when it hits something, it's going to make a big impact and it's going to send so much stuff flying off the surface, okay? The Earth has craters and the moon has craters. But some of you astronomy enthusiasts might be thinking, well, if both of them get craters, why does the moon seem to have so many more than the Earth does? Well, that's because the Earth is covered with an atmosphere. We have a nice protective atmosphere around us, but it's very thick. So when something is traveling really, really fast and it goes through the atmosphere, there's so much friction, it heats up, and it actually burns most anything that comes through our atmosphere. So we really don't get many craters. We do have some of course. You might know that the asteroid that eventually killed the dinosaurs during the Cretaceous period, we think it was around 7 miles wide. So it must have been really huge for it to make it to the surface of the Earth and be that big. But the moon looks like it has more craters compared to its surface size because it doesn't have an atmosphere. Okay, so there's nothing really to burn anything up. Alright, so anyway, we're just going to do a demonstration. I'm going to show you how meteors, comets, asteroids can make craters. Now what I'm going to do to show you that is I'm going to use this mashed potato mix that I made here. Alright. And we are going to put a bunch of it in a plate inside. So, let's get in a little close here. Go ahead and push some on in there. Not even be able to get all of it. Imagine eating nothing but this for your dinner. Okay. That's pretty good. Got some of it on the ground, that's okay. So what this is going to simulate is the surface of the moon. Okay, or really it can be anything, it can be any planet. We're just using the moon as an example, okay? Because it's easy to see craters on the moon. Especially if you've got a pair of binoculars or a telescope. Okay. Let me flatten that out a little bit. I think that's pretty good. All right. Now, we also collected a few rocks, just walking around our wetlands out here. So we got some of different sizes. Okay, so we got small one here, another little small one, then we got some more medium-sized ones, then we got a couple big ones like this. Now, I want you to think in your mind, when I throw this at the surface of our mashed potato moon, what kind of crater it's going to make, okay? So, let's go ahead and take one here. And all I'm going to do with this one here is I'm not even going to throw it, I'm just going to simply drop it. And I want you to think in your mind, what will happen? Let's see. So, if we get in close there, we can move up close. See, that made a little bit of a dent. All right. Now let's say that meteor wasn't moving very fast, but now we have a really fast one coming in. Okay, so I'm actually going to throw this one. See what happens. Little bigger. Okay. Now, not only am I going to throw one, I'm going to use a bigger one. So what do you think will happen if I throw a larger meteor at a high speed into this mashed potato mix? Let's see. That's what happens. You get mashed potato moon all over yourself. Now, so you can imagine what a really big asteroid can do to the surface. Remember, these meteors can travel at thousands of miles per hour. So even though the size of it, this is bigger, but you actually end up getting crater that can make it look like it was way bigger than it actually was. Okay? And now, one more thing. Let's see what happens when you throw it at an angle. Okay? See that? So if you look at that trail there, okay, you see it was ejected out and then it all fell forward. Okay. Now imagine you're on the moon, or well, of course you're on the Earth, flying around in space. Something hits like that, and then you look up at the sky, and you might be able to see this trail of pieces of the Earth or pieces of the moon if you're on the moon, just flying out in one direction because it was at an angle. Okay. Now, let's do one more. I'm going to go a little bit slower on this one. All right, I think that's perfect. All right, now I'm going to take this out. I think that's pretty good. Okay, so now we're going to go a step further with this. So did you know that the moon actually has ice on it? I'm about to explain why. So it has something to do with the rims of the crater and the way the angle of the sun hits it and creates a shadow. So we're going to do that right now. All right, well, I'm back inside. You can't see anything right now. I'm in a dark corner of one of our rooms. Okay, so it's a perfect spot to show you how light from the sun can cast shadows on craters. So I'm going to go ahead and turn on my light. All right, so, that crater, you can see right there. Remember, that's the last one we made. All right, now, if you look closely, you see there's a shadow. Shadow is on the left side. So the part on the edge of a crater that lifts up just a little bit, that's called the rim. If you can maybe get a little better view there. That's the rim of the crater on the edges. And like I said, on the left side, you see a shadow. And the reason for that is because our light, or our sun, is coming from the left side here, this direction. You can see more shadows. The further I stretch it out, and the lower, oh, there you go, the lower I hold it, the longer that shadow appears. Now, of course, everything in space is moving. It's rotating. It's also revolving around things. So the Earth rotates. The Earth revolves or orbits around the sun, but also the moon orbits around the Earth. Okay, now, of course, when the sun hits it, that's going to change the angle. Okay, so I'm just going to move my flashlight around so you can kind of get the point here. Okay, so if you can see on the edge of the screen there, my light is moving. But what do you notice about that left side of the crater? I'm just going to move slow. So there's a little bit of change, but it's still mostly in shadow. Okay? Now, there are some crater rims that are so steep, and because of where they are on the moon, like on the south pole of the moon, they're always in shadow no matter where the sun is. That means it's always cold. In fact, no warmer than, say, around minus 250 degrees Fahrenheit. That's pretty cold. So that means then that those parts on the craters, they're actually containing ice. Yes, there's actually ice, a little bit, in parts of the moon. And you know, someday, when we maybe make a lunar base on the moon, maybe as a staging point to launch missions to Mars, we might actually be able to use some of that ice and melt it and use it for water. So yeah, that's pretty cool. Well, I hope you enjoyed this. And again, this is Mr. Tom from the museum at Prairiefire. Have a good afternoon.